Should I switch over to the actual slides?
Hello everyone. Today, Jost Migenda will tell about profiling and optimization in Python.
Excellent. Hello everyone. And yeah, this is work that was started by Robert at University of Sheffield, and I'm now a co-maintainer of that course. Now, one of my favorite bits of advice for new PhD students is this. You know, you may think you're doing a PhD in astrophysics or whatever subject, but really what you're going to do is a PhD in problem solving with some occasional applications to astrophysics. Right? Really what you're going to be doing day to day is you're going to learn about a couple of different statistical methods. You're going to learn about random bits of internals of SciPy.integrate or AstroPy.coordinates or other modules relevant for your work. You're going to figure out how to submit jobs to your local HPC cluster and learn way more about how Slurm works than you ever wanted. You're going to figure out just enough about Git, Vim, Bash, and many other tools that you need to get stuff done. You're going to learn about admin procedures in your department or your university, and much, much more. So you're going to learn a lot of stuff during your PhD. But do you notice something that's not on there? There's nothing on there about you will take plenty of time to thoroughly read and understand the documentation of software tools you're using, understand underlying principles and their performance implications. That's not on there because you don't have time for that during a PhD. So most researchers writing software are not software engineers. They're not classically trained programmers. They pick up just enough to get their work done. Right? They learn organically. They pick up what we might call unpythonic habits, which lead to their code being less efficient, less performant. And most of the time, that's fine. Right? Most of the time, their code is good enough. It runs fast enough on modern CPUs, so yeah, it doesn't have to be perfect. But at some point, some researchers will hit a stage where it isn't fast enough anymore, right? Where they have a large data set, they run their script, and it takes hours to complete. And they're stuck waiting. Now the good news at that point, or maybe the silver lining, is that since that code wasn't optimized in the first place, there's still plenty of low-hanging fruit there in terms of performance. So a lot of the time you can make that code 10 times faster or so by changing just a few lines. And this is what this course we're developing is all about. Right? The goal is not to achieve the highest possible performance at all costs. The goal is to achieve reasonable performance and to make this reasonable performance easily accessible to researchers. Right? So at a very high level, there's 2 steps to achieving reasonable performance. Step 1, figuring out which parts of the code are slow, and step 2, making them faster. Profiling and optimization. So we started to develop a course on Python profiling and optimization aimed mainly at researchers. So over the next few slides, I'll summarize the main contents of the course. we start with a profiling section. And the first thing we talk about there is the Python standard library's timelet module, which, yes, technically isn't real profiling, but it works. It's really easy to get started, and it's a damn good start. Right? You can do a lot with just that. But then we get into a little bit more advanced profiling. We talk about the C profile module from the standard library, both on the command line as well as with this nice visualization to figure out which of your function calls are taking up most of the time. And then for people who need to dive a bit deeper into the function, we have a section on line level profiling using the line profiler module on PyPI. And there you can get actually this line by line view of which lines of your code are taking up time. So with that, we figured out which parts of the code take up most of the runtime. And if we're delivering this as a one-day course, this usually takes up most of the morning session, going through all these and then doing some practical exercises. And then for the rest of the day, we will focus on those slow bits of code and figure out ways to make them run faster. But before we actually edit any code, we ask the learners to consider, if I edit this code, if I make these changes, will those actually, save you enough time to be worth the initial effort? Right? If the script takes just a few seconds to run, and I don't need to run that often, then it doesn't make sense to spend an hour trying to optimize it. We ask learners to consider, will this change make the code harder to understand and maintain over time? And sometimes that's a reasonable trade-off, but sometimes it isn't. And then we ask them, if you're changing this part of the code, how large is the risk of introducing bugs? Do you have any test cases you could run to verify your code still works the same, still gives the same results after that change? So in short, is this change worth the trade-off? Because we all remember this famous computer science quote about premature optimization. And then after this intro, we talk a little bit about the internals of CPython, how it works, why it is slower than languages like C, and why having this overhead with all the metadata in each object header is actually useful. And then after that, after this really important intro, we go into different ways to optimize the code. First one, very basic, talking about language features and using the standard library. And a very common pattern in code is using the for loop to iterate over a list and do something with the elements. And a lot of the time, there are these built-in functions like sum, min, max, etc., which can replace the need for a for loop and make the code both more compact and more readable, but also faster at the same time. And then something I've occasionally seen is that people are not familiar with the standard library and they re-implement stuff like, for example, string.split. And using the standard library is not just a lot easier and is one line of code as opposed to 10 or 15 or however much people write. But it's also faster because it's been optimized over years by people who really care about those details. And people have thought a lot about edge cases, where one PhD student just trying to get this to work will not worry about those. And often enough that will come back to bite them later. So we talk about using standard library functions where possible. And often some of these, just replacing the for loop with a built-in function, can give you something like a 2 to 8 times speed up. Next, We talk about basics of data structures and algorithms, talk about how lists and dictionaries work internally, and explain why, for example, list comprehensions are often faster than running list.append in a loop. And we talk about why some tasks like looking up elements or removing duplicates can be thousands of times faster if you use a set instead of a list. Right? In this code example at the top, you just change a list to a set, and that can take it from 20 minutes or so for tens of thousands of elements, from 20 minutes to under a second. So that's a huge boost. We then talk about NumPy, how NumPy's arrays are different from Python lists, and how array broadcasting can give you an order of magnitude speed up for many tasks. And since the audience can be researchers from many different areas, we also talk about many other packages that use NumPy under the hood. So you can get similar performance boost in many of these other packages. And finally, we have this kind of grab bag section. We talk about make sure to update to the latest version of CPython because you get some speedups for free, especially in 3.10 to 3.11 transition, but also later. We talk about disk or network I/O latency. We have an example of using a thread pool executor to parallelize some tasks, and so on. And for these, the impact will depend a lot on the use case. So that's a brief summary of the contents of this course. Now, over the past 2 years or so, we ran a couple of pilot workshops at University of Sheffield, King's College, and other institutions. And I just put up some feedback from a workshop we ran in February, where the feedback we got was that most people found that this workshop was really immediately useful to them, right? They could immediately apply what they learned, and that was reflected both in the star ratings there, but also in the text comments that we received. And that tells me that we're achieving our goal with this course. We're tackling low-hanging fruit, we're achieving reasonable performance, and making it accessible and relevant to researchers. Right, so that's been really good to see. We also learned that designing this kind of intermediate level workshop is actually quite tricky, right? If you have a beginner's workshop, you can make sure everyone has the same setup. For an intermediate workshop, people have lots of different setups, using different package managers, different environment managers, executing their code on as scripts locally, or Jupyter notebooks, or on HPC, and so on. So there's a wide variety of setups, and that often leads to some debugging issues we have to do while running the course. We also found that because we have researchers coming from many different fields, it's hard to find examples that are relevant to them. And we are trying to get some examples from different fields so we can customize that for each audience. And we also found that following the structure and principles of software carpentry's courses has been really helpful. So next steps right now, this course is on the Carpentries Incubator, and it's in a beta stage, which means there are some known areas for improvement, but it's ready to be tested at more institutions. And the goal is to go out, test it with many different audiences, prepare it for a more formal review, and then reach stable status, and be included in the Carpentries Lab, which is a collection of these more stable community-contributed courses. And I'm talking about this here because I want you to help, right? I would invite you to run the course at your institution, ideally with 1 or 2 colleagues. Usually the way we do this is one person is leading the profiling part, one person is leading the optimization part, and then there's often a third person who's available as a helper throughout the day if 1 or 2 of the learners have difficulties. you can also, if you don't have colleagues who will run this with you, talk to me later, see if you can, if you have some travel funding, invite me or Robert or colleagues to help you run this. And once you've done so, please open a GitHub issue, give us feedback, tell us what worked, what didn't. You're welcome to contribute to the course materials themselves, obviously. And if you have, maybe more niche profilers or other optimization tips for less common libraries or other languages, they may not fit into this course in particular, but we're also building a profiler and optimizations database online, where we would love to have more content. So in conclusion, we have this new course. The goal is not to achieve the highest possible performance, but to tackle low-hanging fruit to be immediately useful to researchers. Contributions are welcome. Please talk to me afterwards, and I welcome your questions.
Thank you, Jost, for your insightful talk. Please ask your questions. Questions about optimization.
Hi, thanks, really enjoyed the talk. I guess when designing looking at a lot of the projects that implement benchmarking and stuff, a lot of them use ASV, ASV velocity, which is, I assume would have been included in this course. I guess my question is more general, it's were there things that are used a lot in the benchmarking community that you're debating whether to include in the course, and how did you go about reasoning with that?
We haven't had these discussions, no. I don't know if benchmarking itself would be directly useful to researchers. I think that becomes really important if you're going for the higher performance, but if you're just trying to get stuff done and make your code fast enough, I'm not sure where that would fit in.
Sorry, I'm not entirely sure the difference. Okay. I'm not really entirely sure the difference in terminology between benchmarking and profiling. I kind of use them synonymously, but maybe that's my fault. What's the distinction between them? Between benchmarking and profiling? Or is that, maybe that's too difficult to get into now?
I think it depends on who you ask, probably.
Okay.
There's some overlap in the definitions.
Okay, thank you.
So often when you have this situation and you need to make your code faster, you have two ways of doing it. One is really tackling the execution speed, which is what you are mainly doing. The other one is algorithmic changes. I mean, you talked a bit about using the right data structures, but especially in these scientific fields, you often have just the ability to choose different algorithms. Do you think that this is something you would long run want to have in your course, or are you already touching upon it?
I think it's difficult to include in a course like this because which algorithms are fastest depends on your use case, and sometimes on the exact characteristics of the data set you have. So I think it's going to be hard to include that in a fairly broad course like this, which is aimed at researchers from across different departments.
Yeah, so I think the only thing you could do is maybe for canonical problems like integration or optimization, help people give people strategies of how they can choose things or how they can try out things. But,
yeah. But there, a lot of the time, the default answer is just use SciPy.integrate. and I think if people are at the point where they have to think about, okay, which integration algorithm is the right one to use here, I think that they're already in this kind of high performance area where they will look up in the SciPy documentation for details. So I think that's kind of beyond the scope of this course.
More questions? Have you ever tried to make your code faster? So if you ask a question now, probably you will have to wait a few times later in the future. So instead of waiting 20 minutes in future, now you can ask questions for 1 minute and your code will be faster.
Yeah. Maybe the best or most impressive example I think we have in the course is a real example from a colleague of mine who was in bioinformatics, who had this script to analyze some image data, figuring out like which points of interest are located in which cells, and was looping over a whole lot of cells, and had this script which ran for 20 hours. And then she we noticed, hey, this library, this geometry library, is actually using NumPy under the hood. She used array broadcasting, which was like 10 lines of code change, and went down from 20 hours to about 20 minutes.
The same as 1 hour of debugging may save you 1 minute of reading documentation. 1 hour of waiting when your process completes, it saves you like few minutes of working with profiler or implementing multiprocessing in your code. So do you have more questions? We still have a few minutes. Okay, thank you, Jost, for your insightful talk.
Thank you. And yeah, feel free to come up to me later if you want to talk about running this course at your institution.
Now we have a 10 minutes break.
Cool, I just tried it before, I'll put in. Ich habe auch schon mal Programmierkurs an der Uni unterrichtet.
So we will talk about solving hard optimization problems with PyOmo and
Heiß. It's like hard to pronounce.
Yes.
I checked it myself too yesterday evening again. How this library is. So it's not my library. It's just a nice open source library. It's Heiß. So a little bit like high and an S in the end.
okay, Heiß.
Yeah.
It's like in Jordan. Your name,
yeah,
your name is
Yeah.
Heiß Florian.
Yeah. Yeah.
Die Leute aus verschiedenen Fachbereichen. Da ist es schwer.
I know about PyOmo. I had course in optimization. That's not
okay,
Heiß.
so
Wo man dann das
usually then know most of my talk. if you had this as a
Nee, aber
Ja.
gut, ich werde es mal noch genauer anschauen.
course.
Okay.
So where did is this
I
thing?
think one of them. Let me see. This is Logitech, but what is this I do not know.
Okay, this is the one I brought, but if this is also working,
Yes.
yeah, then I don't need this actually. Good to know.
Yes. So it's plugged in
It's
here.
plugged in here. Okay.
Instead of Logitech, it's written just Logi.
Yeah, that's really old, and yeah. Nice. So there's one more talk after mine, right? Or is it?
Yes, you are in the middle. And we have a bit more time for questions because it will be not 10 minutes, not 5 minutes break, but 10.
Yeah. Okay, then maybe I'm also.
So
maybe it
they-
takes also a little longer than 15 minutes. So, but yeah, we have a buffer, right?
Yes, we have spare time. For that. I think we have to finish like 25 past 4.
Yeah.
And I think that's what ASP velocity calls, but I'm not entirely sure. So that's, I just want to, from the whole project perspective. Besides, I'm not sure.
One, two, three.
So up to you, you can use this or microphone. So there might appear creepy sound. If it appears, I'll immediately prepare
Okay.
a classical microphone for you.
Okay.
Now Florian Wilhelm will guide us through solving hard optimization problems with libraries by OM and HEIS. Let's join me in welcoming Wilhelm.
Yeah, thank you. And so welcome to my talk about Payomo and HEIS. Maybe a few words about myself. So I have a mathematical background. I'm head of data science at Innovex. We are a consulting company, IT project house. And since I have a mathematical background, I'm especially always involved in like more the traditional optimization kind of projects, classical machine learning, not so much AI. And of course, we also use a lot of open source packages and are contributors. So to get you started, what we're going to talk about is linear programming. So basically, it's another word for optimization, and maybe some of you may know this from operation research, or if you already heard something about optimization. Typical, like standard formulation optimization problem of a linear one is that we have some kind of cost functional, like this C times X. And we want to minimize it, and we have a certain set of constraints given by parameters A, some matrix times X is smaller or equal than B, and we want to find now some vector X from the real numbers, which minimizes this. And if X is from the real numbers, then this is kind of easy to solve. Maybe some of you have heard of the simplex algorithm. And this solves it in cubic, and there are other ones which are a little bit less, so it's still, cubic is quite a lot, but it gets worse if we now say that some of our decision variables are no longer real numbers but integers. Then this problem becomes really hard, NP hard actually, so the complexity grows with the number of those components which need to be integral. And you cannot just kind of throw this away, those additional constraints. This would be called a linear relaxation. I'll come back to this, because in the end you don't get always a solution that is close to an integer one, like solving this and rounding is not something that gets you the solution. Besides the linear cost functional, there's also other variants like quadratic programming. Then if all of your decision variables are or need to be integer, then you have an IP, an integer linear program, or sometimes it's more like a binary, then it's called a 0-1 linear program. And what the nice thing about this whole topic is that this standard formulation we've just seen can be applied to a lot of problems, like the problem we had at PyData the last 3 years, that you have to schedule some talks in an agenda and you have different constraints. I'll come back to this in a use case. So all kinds of allocation problems, in schedules and so on. Also transportation problems, so factories, and you have consumers, and you need to decide which factory delivers to which consumer and so on. You have also shortest path problem as a classical problem, where you have costs, where you have a graph and you have costs on each edge, and you need to decide which path you're going to take. And also the maximum flow problem, for instance, imagine some electricity network, and you're asking yourself, so how much power you can get from A to B using the whole network. And all those can be, in principle, then be modeled to get the standard formulation we have just seen. And now you might ask, okay, it's NP hard, so this is really problematic. How is it then solved in the end? And there's heuristical methods. In principle, of course, they cannot overcome the boundary of being NP hard, but in practice, they deliver a solution then in a time that is somehow acceptable. And one method is called the cutting plane method, the other is the branch and bound method, and they are often combined as the branch and cut method. And just to get you an idea how those work, it's like really simple. So what I said in the first slide, did you kind of just throw away the additional constraint of those x's being integer, so you relax it, and then you get a solution using, for instance, the simplex algorithm. And while the solution is not integral, you add additional constraints that kind of cut away the solution you have without cutting away the kind of integer feasible points. And then you do this again and again. And by this, you after a while, you end at a solution, especially when it's combined with branch and bound. And branch and bound has a similar idea. So again, you solve the relaxed linear problem. And now you look at your vector. And for all components that are fractional, that are xi, you round up and down, and you add additional constraints for those components. And by this, you build a huge graph. And in this graph, you can decide if it makes any sense to go down that path by looking at this inequality, since we all know that the feasible solution, or your cost functional evaluated at a feasible point, is always smaller, equal by definition than at the optimal point, of course. But this is always will be smaller than the optimal solution of the relaxed problem. And if there's a contradiction in this, you know, okay, I don't want to go down that path, and so you eliminate variance. And this is then implemented in the typical solvers. So to show you how this works in practice, imagine again the use case. Like we had at PyCon, so we have a lot of talks, and then we have a schedule, and we want to fulfill the certain constraints and assign each talk to a certain slot. But we also did something like this, for instance, for assigning beds to patients for a customer in a huge clinic. So these are the typical problems. So just to talk about different constraints you're going to have in a use case like this. So, of course, each talk must be assigned only once. Then each room time slot combination can only be occupied by one talk at most. Could be that some are empty, but in principle, of course, would be kind of funny if a second person was standing next to me also talking. So no more than one person. The length of the time slots must match. Makes also sense. And sometimes you may have tutorials that have a part 1 and 2, and you should make sure that they are in a consecutive order. Then more interesting is the objective. So what makes up a good schedule? I mean, the most important thing is that if you talk to the speakers and they give certain preferences, that those preferences should be fulfilled. Could also be done by a constraint, but maybe then the solution, there is no solution, so better to have it with preferences within the objective. And then another thing, since for PyCon, PyData, we had a voting beforehand, so we knew already, okay, those talks are really popular, and that also means you can assign them to certain rooms with a higher capacity. So the difference can be part of the objective then. Also, you might want to avoid parallel talks to which a lot of people want to go at the same time, because then it's not possible. And also, since if you have many tracks and you don't want people going around the whole time, changing rooms, you might also think about, okay, let's keep talks that have the same main track in the same session, and even for the sub-track. So since now we have a lot of objectives, we have to give them some kind of priority order, and we just kind of prioritized 1 over 2 over 3 and so on. So now, how do we solve this? So there's Pyomo, open source package. I really like it. And it allows you to define what we've just seen in a really Pythonic way, and what it gets you is this kind of standard formulation we have seen before. Most often you save this as a so-called MPS file, and this is all Pyomo does. It's not actually solving it for you, it just kind of gives you this standardized formulation, which is a huge file. For instance, just to give you an idea, it was about 100 megabyte in our case. And then you use any kind of solvers, and especially for integer programming, the Heis solver is really good. And you apply it on this MPS file to get the actual solution, and then you can kind of read it in again to do your analysis in Pyomo. So yeah, this makes it really modular and flexible. So how does this look in practice? So with Pyomo, imported as Pyo here, we just we create a model, and then we define a lot of index sets. And those index sets, they help us to later define parameter and constraints, and they give us a nice naming. So instead of having a lot of indices, we rather define this as a kind of tensor. So we have, okay, so we have all the talks, then the days, Wednesday, Thursday, Friday, and always a morning, afternoon, and a second afternoon session, and so on. In the slots for every session, there's a first, second, and third slots. Of course, we have the room, and so on. And with those index sets, we can now start to actually define parameters like the preferences that we talked about. For instance, let's say sponsor talks, they don't want to be in the small rooms, and they maybe also don't want to be Friday afternoon because then it's kind of hard to talk to them. So in all combinations of the parameters that we see here, so this init slot preference is used and goes really over all combination, and those are quite many if you multiply their magnitudes. Then in all cases this is fulfilled. We say, hey, it's a 1, so if this is true, and -1, for instance, in this case we wanted to have that the second session rather stays empty if possible on Friday afternoon, and 0 just for the neutral case. And with this kind of initialization, you can easily initialize all your parameters. Then comes the actual decision variable. This is the schedule, and of course it's a variable over all those talks, over all those indices we just defined. So just, how do you read it? If now, let's say we fix one talk, and then over all the other indices, there should be only a single one, right? So it's really completely, multiplied of all combinations, and this is how we need to do it because it needs to stay linear. And now to define, for instance, constraint, it makes sense to define auxiliary variables, and here Pyomo gives us expressions if this auxiliary variable can be deterministically defined. For instance, if a talk is in a room, then I can just sum up over all the other index variables, which are the days, the session, and the slots, and so on. And for other auxiliary variables, they stay variables, and so they are fitted by the solver, like if two talks get a 1 here, if two talks are parallel. And then we define the constraints. So the simplest one that I just showed here is that if we fix one talk, if sum up over all the other indices, then there must be 1, so it's assigned once. And for the room, it's kind of similar. Here we have a smaller equal 1. This we do now for all our constraints that we just talked about. So quite Pythonic to define it like this. Now coming to the objective. So if we have now all our parameters set, like the preferences, we have the actual schedule. We can, for instance, this one term in our objective is then just the dot product of the preference parameter and the schedule. The same goes for the room capacity with the popularity. This is where we kind of give a penalty if a really popular talk is assigned to a really small room and so on. And the prioritization we set, we just solved by moving all those terms in a different order phonetically queued, and by this combining those multiple objectives. And this you add like the constraints and like the parameters just to the model object, and this pretty much is everything. So now, how do you solve it with heights? As I said, there are two ways. You just write it as an MDS file and call heights on your command line, or you can also run it directly in your Python code. But always be careful. Even a seemingly simple optimization problem like this runs for 4 or 5 hours. And this is how you just take the solver, you can define some parameters, like in this case I want to let it run only for 10 minutes and take the best solution I find within 10 minutes, and the solver loads then the variables back so you can do the analysis. And if you are interested in more details, the code is also online and you can find it in our Pythonist package. And currently some parts are under construction, mainly because the pre-talks API changed, but this is completely independent to the optimization part. So if you want to check it out, you can try it. A few references. You also find the link to the slides if you want to read more about it. And with this, I want to say thank you. And if you have questions, let me know.
Please ask your questions. Florian waits for your questions about Pyomo, highs, about all this integer mathematics, optimization.
How many of you have had a problem like this? Like optimization problem? Okay, and did you also use Pyomo or Pulp or one of the... No.
So for me, I didn't solve it.
Okay, it's also a way to optimize it. But we also have one question over there.
So you said that this sort of simple example takes a couple of hours to solve.
Yeah.
I mean, this really surprised me. Not that I have any comparison experience values, but it also feels like it's tricky. I mean, you set it up, you run it, and 4 or 5 hours you realize, okay, that was a mistake.
Yeah.
Can you have some intermediate result and check if it is really doing what you think it does, or?
Yeah, you get, that's the good thing about the whole math behind it, that you always know how far you are away from, at least you have boundaries, like with a dual solution and so on, you know that this is kind of your left and right interval of your optimum, and then this interval gets smaller and smaller, so actually like the first 4 or 5 minutes, it just tries to find any feasible point at all, so that all constraints are fulfilled. And from that point on, it goes down. So if you stop it at any point, you have a solution, and it also tells you, so this is how far at that point the solution is away from the optimum as far as I can see it, because yeah, it's always kind of two intervals getting closer and closer together during this process. Yeah, and yeah, in practice, how we did it, so we stopped it several times and then looked at certain intermediate solution if they make any sense at all, and and the thing is with this, so I was also astonished and couldn't believe it at first that it takes so long. But that's really the thing with the NPR hard problems, that it's combinatorically. I mean, if you would try everything out, then it's 2 to the power of then the number of days, the number of slots, the number of talks, and then you end up with something in the 10 or hundreds of thousands, and then 2 to the power of, so it's really exploding,
Some more questions?
Thank you for your talk. I have a question about how you define the interfaces of like how you input the data, because from my experience, when there are a lot of NP-hard problems, and once you try not to define the mathematical problem with linear programming, and try to make some high-level definition of this problem, it's hard to make it general, and that's why the use of tools other than simplex solvers or something like this is complicated. So yeah, my question is, like, did you have a set of tasks that you wanted to solve, and you tried to understand how you should design these input interfaces, how you describe this task for user, and then try to add new tasks. So how this was developed? Because I think it's one of the most difficult things with development.
Yeah, and that's a good point. So in the end, the link I gave there is just a Jupyter notebook, and it's actually kind of horrible. And every time we use it, then 1 year after, you make a copy of it and change the parameters, because it's like really hard to have a kind of user interface. Because for instance, if someone wants to add a new constraint, then it's not like, so I imagined it at first, I want to have kind of one function where I put everything in, and then Payomo is somehow hidden in this function and gives the definition, but it changes like every year, and we did it like for the 3rd year now. There's like new constraints or constraints coming out, so or falling out. So for instance, one constraint was that 2 talks should be at the same time, one in the morning and one in the afternoon, because it was a couple and they had to make sure that someone takes care of the child. And this constraint, we had 1 year, because they said, okay, we are only on this day, and the talk, and if you have additional constraints like this, I mean, then you start going back to modeling. So, I don't know if this answered your question.
So when you have some practical use case, you try to like tune this mathematical model at first, and develop upon it. So you have some core and
So then,
Have you considered alternative approaches, like machine learning models, neural networks, different things to probably find a quicker solution?
Yeah, there's actually some startup which came to me, and they have a completely different solution. They take this kind of Payomo model, and then they sample from it all possible things, and then they learn a neural network on it, and then they optimize not this NP-hard problem, but they have a way of optimizing or finding the right parameters for the neural network, and then somehow projecting this back to get an actual feasible solution. So I don't know exactly how it works, but this is kind of really interesting. This is kind of how you get around this NP hard in a somewhat tricky way. But of course, they also don't break the theoretical rules. So,
is it possible to provide a baseline solution, and would that help in the optimization process at all?
Yeah. So if you like the first like up to 10 minutes in this case, it was only trying to find one feasible solution at all. So if you can easily define a feasible solution, then you save 10 minutes, definitely, yeah.
But I mean, you cannot give it one that you think it's not so bad. You know, to give it one not only feasible, but one that maybe, you know, that's not so bad, but I would like to optimize the solution.
That's a good point. So I don't know how I can push into highs also like a starting point or so. I don't know, but should be possible. Yeah. This could be a good way if someone says, okay, I can maybe do it better by hand to kind of push this in this first handcrafted solution and see how much better the solver gets, maybe. Yeah.
Thank you so much, Florian.
Thank you.
The next talk in this room will be in 5 minutes, and it will be about computer vision and chess, how computer can see figures and play with you.
Sorry for the issues with electronics. I just think that because of this is university, so it's mostly our professors who do lectures every day and they know every issue with electronics.
Yeah.
But here people are coming for 20 minutes and of course it's not enough properly work.
Okay, this was it was not loud enough, right? No one could hear me, or was this sound? Because I didn't hear the sound.
Probably it was just...
Okay. That helps, yeah. But yeah, thanks for the moderation.
I had a optimization course last semester. And, I've never heard about it before, and it really highlighted me that it exists not only in my university.
Yeah.
And the company is really working with it.
Yeah.
Cool.
Do I need to do something about the keyboard? This is not quite right.
Oh, always keep it. It's one of Apple. They always try extra ensure that it might be keyboard, and this keyboard might be Japanese,
okay.
And it doesn't work in another way.
Okay.
Yes, it works.
Let us test it.
talks are 20 minutes now. So now I turn it on.
1, 2.
So you can put it in your pocket. And your things will be recorded from.
I hope I'm audible. The people at the back, am I audible clearly? If you can raise your hand, if you can hear me clearly. Okay, thank you. So, hi everyone. So today I'm going to show you how I taught AI to watch the chess videos. So you don't have to suffer through the boring ones in the YouTube. So this is going to make it more interesting, like a Netflix with chess, with some funny jokes, so that you can enjoy the whole process. So about myself, I am a master student in AI in Event City School, which is located in Paris. So I am also an AI engineer at IMSIL AI and a lead data scientist in AI Recruiter. And my fields cover like digital marketing and industrial marketing, real estate, and recruiting, arts and education. So I wanted to combine two of my passions, AI and making the complicated things less boring. So I hope you will enjoy my project. So let's start with the problem. For example, if you watch the chess videos in the YouTube, it's pretty difficult to follow. If you're a beginner, you will lose the whole flow in just 2 moves. And if you're like advanced player, you will feel like you're watching a whole video in terms of a math problem. Like you feel like you're starting a math class instead of enjoying a chess video. So it's pretty much what we want is someone to explain us the whole video, making us not feel like we are doing some PhD in pawns. So this is my solution, which would be combining the computer vision and combining them with generative AI to make this whole process pretty fun and pretty educational. So how my system actually works. So we got some video input, which could be a YouTube video or any other video input. So that's going to be fed into the system for real-time processing. And then we have AI detection. So here we have the YOLO V8 version, which is going to track the pieces and it will identify the board positions accurately. Then we have the move transition, which is more like it will detect the pieces and how they are moving on. And then comes the LLM part, which is going to give some commentary generation so that you will understand the whole process as well as enjoy the strategies. So coming to the data set, so I have took a data set from RoboFlow collection, and if you can see, I have used a library from RoboFlow using the API key, and I think this will take a bit time, but I wanted to show the dataset how it works, some analytics of it. But in the meantime, we will try to cover a bit what exactly is the dataset going on. So in the collection, we have some thousands of chessboard images. So they are being in different styles, like in different angles, in different lightings. So all of this will cover most of the scenarios that could possibly happen in a video. And not just that, the dataset itself serves a purpose because not all the videos are recording in the same way. Not all YouTubers have this rule that, okay, let's just shoot like this. So that's where we need this data set. Okay, it's ready. So here are the number of images and some annotations that we have for the data set. And if we look at the classes, we have all the pawns, which are like the 12. And then we have, if we want, we have some insights of the dimension of the image. And then we have the annotation heat map of all the annotations that we have done. And then we have the histogram for the object count of the image. And coming to the next part, so what we want to do is piece classification here, so that we can classify each piece in the keyboard, in the board. And we have the AI, which will take the strategy from all the labels which are detected. So now training the model. So how exactly it works? So the whole thing pretty much is the YOLO V8 architecture. So here so here we have so here we have the model and the target, which we have the map 50, and then we have the results, which are like which is the model trained on the data and the epochs. So I have kept some metrics in the training so that if it has like good performance, it's going to stop. So the GPU, I have used T4 GPU, so it took like some 80 minutes, and pretty much I got good accuracy here and some efficient conversions. So if you can see, I got 11 epochs. It just finished in 11 epochs, which is a pretty good thing. And I got all the classes, the images, and pretty much good accuracy overall. That means the model is working pretty good. So now coming to the favorite part, the LLM, which is going to give us pretty witty commentary. So this is what going to make the whole education fun in terms of chess. So you're going to pretty much believe into a whole new personality in each video, which will depend on your own personal interest, which will pick on all the analysis and strategies from the video, and it is going to give you back some text to speech. That is what I have also included, a text to speech technology. So here you're having a whole new experience, pretty much fun again. So overall what I have achieved, so we got some pretty good detection, it is 99% accuracy, and we got some pretty good real game processing, and we also got some pretty much good engaging commentary, and we also got some audio narration and a complete solution. So this is the LLM part, where we used a pretty much simple prompt, like how it should be as a commenter for the whole video, and we just asked it to be a pretty good humorous commenter. So what could be better? So here we do have some video format limitations, because not all angles in the video could be good. Some could be have taken from pretty far distance, or it could be at the bad lighting setting. So here we still have some angle sensitivity in terms of the board and the lighting, like I mentioned. So what we are trying to do is, as a human, we still can't recognize it if it is in bad condition, so I can't be too hard on my AI. So I'm just hoping it is doing better than me at some part. So what's next? So it's going to be a pretty much intensive later on. I'm hoping it would be much more educational than it is now. So it's got to be having a real-time streaming analysis, which is more like we are analyzing the chess games as they happen live, where you can get to have your own education while the live game is going on, and a pretty much interactive Q&A. If you want to have interactive with the chat GPT or any agent, you can stop the game in the mid and you can ask the questions. And we have the pretty much grandmaster stockfish, which we can integrate it into the system. And not only that, we have pretty much everyone knows chess, so we can maybe implement all of this in a mobile application, making it accessible to everyone. So if you want to learn more, you can either contact me in the LinkedIn, or you can read out the article which is published in IEEE magazine. So pretty much you can also find it in GitHub repo. And all of this is, all of the links are already mentioned in the schedule where you can find my page. And thank you.
Thank you, Likita. Thank you, Likita.
Maybe use better microphone now during Q&A session.
Thank you, Likita, for your amazing talk. Now we have a few minutes for questions.
Can we see a demo?
Yes.
Not yet. Yes.
So this is the interface I have built a few months back, and I think it's not pretty clear in the quality, but I guess you can understand the process. So you basically drag and drop the file that you want the analysis on, and I just put a YouTube video, more like a YouTube short, and after, I think it will take a couple minutes to get analyzed, and after that it's going to get uploaded. This is the video I have chosen, the Queen's Gambit, which is a pretty famous strategy in chess. So after the video is uploaded, it is going to detect the chess pieces in the video. So you pretty much sees everything, and sometimes when there is a strategy going on, it is going to detect the positions and everything, and you pretty much see what exactly is happening in the video. So it's pretty much fast because I try to make a short video in this, but you pretty much get educated on the strategy here. And after that, you also see all the moves that happen and the chess commentary, which you pretty much might enjoy based on the agent that you have chose. And I added the audio, which will have some voice. It could be any human or it could be an anime character if you would like. So I think pretty much this.
Thank you for this demo. Please ask more questions.
You said that you plan to implement it on some interactive application. So, and do you have any idea how will it happen? Like, because of such as a chess.com, and if you want to implement it on that, so do you have any idea of how it can scale to it?
So what I wanted was very similar to chess.com, but I wanted to make it a bit more fun. What we are thinking is more like combining some frameworks. For example, RAG or LangGraph, which will pretty much cover connect everything. Like how chess used stockfish, we are also trying to implement that because we cannot rely on LLM each time. So we are trying to implement stockfish, which will not just make it like you observed in the video. It took some time to analyze everything, but with stockfish, it will make it real time, so that you don't have to wait till the end. So you can do the interactive session, or you can stop the video and you can ask the questions directly. So that's pretty much what we are thinking to make it real time.
Great presentation.
Thank you.
I just have a question. You mentioned the accuracy is like 99%, right?
Yeah.
Is the accuracy is for the YOLO model or for the LLM? And how do you find that the accuracy? Like, what is the test procedure?
So the accuracy, it's not on the LLM, it's on the YOLO V8. If you have, like, show you.
If accuracy is not on YOLO, then how do you test the LLM? Like, how do you rely on LLM that the commentary is?
Yeah, so for now, LLM, we are not trying to make it hallucinate by using RAG. So here we have to make sure in the prompt that it should not hallucinate and it should not go far from the context. So by putting the RAG, it is going to go first to the RAG and it is going to search the information in the RAG. So after that, if it doesn't still find the information it needs, then it will either give the option either that you couldn't find information on the strategy. That means it's an illegal move. I mean, it's a wrong move. If it is the right move, it will definitely find it in the strategy book in the RAG, and then it is going to add the witty comments on the strategy, and it will give. So LLM is not going to do all the whole strategy analysis, but it's going to assist in the commentary.
Okay, so what was the contest? It is the strategy book.
Yes, yes.
Thank you.
Thank you. Are here more questions? We still have a couple of minutes.
I have a question about video processing. So, did you test it on, like, not on the chesscom, but on the real chessboard?
Yes. The RoboFlow, the data that I have looked, they are like the real chess images. So we consider taking this for the chess detection and the frames as well as for the boards. So basically the whole process from the chess detection and the frame detection and the move detection, they're all trained based on this data set.
Yeah, but have you tried, like, have you tested how it looks on some real videos?
Yes. You mean the images in the game?
Yes, yes.
Actually, we thought to try that, but we couldn't find enough data set. And as you can see, to have access, you have to pay in the chess.com to have access of the games. Because right now, most of the chess games happen in chess.com. And if you want to have data set, you have to be a contributor to the game, or you have to have like a sort of subscription. We try to make it as budget free as possible. So we thought to go towards the RoboFlow because it's an open source data set.
Yeah, but I think like there are some recordings from the chess tournaments, like the reports. Just interesting to see how.
For research purpose we can do, but we wanted to make this educational one, so it's more like going to production, so we don't want to go unethical on that side.
Yeah. And another question about, do you plan to include the information about previous moves for your classification? Because like you have a lot of restriction, and in fact you don't need to detect the whole board, you need to detect only one move.
Yeah.
And that's why even if you miss other figures, if you missed other figures, you can use information from the previous moves to restore this information. So did you have it implemented in plans to correct your mistakes by using information from previous moves?
I think I forgot to show that. Basically, we have in the frame detection, we save each time 5. I mean, if the video is broken into frames, we each time save 5 past frames and 5 future frames to do analysis on illegal moves or repeated moves, or which are like duplicate moves or valid moves. So each time it is going to be repeated. So as we go along, so it pretty much analyzes each time the whole 10 moves together.
Thank you, Nikita, for your amazing talk. Let's thank together Nikita. So in 5 minutes, there will be the final block of sessions. So first, you will be informed about the sprints, which will be tomorrow. So all sprint will be finished around 5 or 6 p.m. So all people are welcome to participate. You don't need any additional ticket for that. Next, there will be lightning talks and the final talk, which is official closure.